sessions that we're going to have, because what I'm going to present is some empirical evidence about some of the issues that Pat has raised. So what I'm looking at is the constancy and ability, the extent to which orientations of pre-service science teachers change, whether we're working in field or out of field, and how those correlate with their beliefs about science. So I'm going to take you through a few things. First of all, I'm always asked the question where Durham is. So this is where it is. We're halfway up the island of Great Britain. So I often say to the British audience we're in the Midlands, but actually we're in the northeast of England. And nobody's heard of us because we don't have a soccer team. But anyway, we have the most beautiful cathedral. It's 1,000 years old, and you're very welcome to come and see it. It's a very lovely place. So there it is in the snow. Right, so as Pat has said, there are some problems with orientations, and I was inspired to look at this once I read Jan and Pat's paper, and as you can see, a few empirical studies actually investigate orientations. There are some different definitions of it. There are links to other PCK model components, but they're poorly defined. An orientations shape PCK, but nobody really knows how that's done. And the 9 orientations of what I've called there the MKB model are inconsistent. Some are curriculum-based and some are teacher goal-based. So what I'm going to do is to add a little bit of empirical evidence from pre-service science teachers to our knowledge of orientations and teacher beliefs. And in so doing, I really challenged my own understanding of this area, and I wanted to look at how they link to teacher beliefs and act as an underpinning PCK component. Now here I differ from Pat in that I'm using beliefs as a different term to orientations. I haven't used them synonymously. To me there's something different about a belief as opposed to an orientation, but we'll see. Okay, so here are 3 research questions that I was exploring. So I should say at this point, I successfully ignored all possible rules that I was supposed to follow in terms of preparing this talk. So I'm really sorry for that. So I have prepared more of a research talk than a discussion talk, but obviously discussion issues come after this. So these are the 3 issues that I'm looking at. What evidence is there that pre-service teachers at the start of a teacher education program actually have any orientations? To what extent are they constant or labile across different domains? And how do these align with their beliefs about what science is as a subject? Right, this is a little bit about the sample, so I'll just say a couple of things about it. There were 235 PSTs in my data analysis. Now, if I'd known what I know now, when I started collecting this data 7 years ago, I've stopped collecting it, I would have done something entirely different. So you have to view this data in that, with that hindsight is perfect. So I'm going to skip over the details of the sample. I collected data using vignettes, so it's self-report on vignettes, and I asked an open question about what these pre-service teachers believed about science, and got them to tell me that. So it was one response. Then I did some content analysis. So we can look at the examples of the vignettes a little bit later if you want. So we'll go to those. There's the 9 orientations. Now, what I'm going to show you next is what those trainee teachers said. I asked them 3 vignettes, 1 each in physics, chemistry and biology, and what were the main responses to the in-field vignettes. So this is when a specialist teacher is responding to a vignette in their own specialist field. What kind of orientation could you determine from what they wrote down? Now you can see here that the items listed in bold suggest that there are very few of those 9 orientations which actually seem to be realistically used. Now to some extent this isn't a surprise, but the domination of the didactic orientation is very clear. And here are some examples of the kind of thing they said. The notion of explaining was very, very strong, and that worked across all 3 specialist groups. So the notion of explaining, telling, describing, or perhaps to some extent experimenting was what composed that didactic orientation. Out of field, here there's a little bit of a change. So people shifted much more towards activity-driven notion. And this idea that perhaps a trainee should be able to play, a child should be able to play with experimental equipment. And in a way, what the trainees teachers are doing there is they're sort of circumnavigating their own lack of content knowledge, perhaps, in terms of doing an activity which was a lot more open and less structured. So as the trainee teacher could not explain, what they could do is allow the child to play. So are these orientations constant or labile? So to what extent will a pre-service teacher respond in the same kind of orientation across all 3 vignettes, or to what extent do they change? Well, having a look at that, you can just see there is no particular pattern. Probably about a quarter of the whole sample use the same orientation regardless across all 3 vignettes. Most of them are different in some way. So they're either in-field different, they have a particular style for their own subject and other styles for different subjects, or they're all different. There is no consistent pattern there that's showing up. Next, let's look at this issue of beliefs about science, and then we're going to look to see how these correlate together. I asked them very simply to say what their definition of the science was, so because I suspect there's some sort of underpinning way of thinking about science which dictates how teachers teach and the way they approach their learning. Now, I had no preconceived ideas about how to code this data, and the 3 categories which came screaming out of it were science is understanding phenomena, it's studying the universe or facts, or it's experimenting or investigating. Those are the 3 categories which came out. Here are some examples of those kind of responses, just to illustrate the range. And the percentages that came out in terms of the 3 samples are shown in this slide here. And what again comes out of that is that the physicists tended to dominate on understanding. They were very much clear that what we're talking about here is understanding phenomena. It's about this background notion, underpinning principles, and so on. As you can see, the biologists and the chemists tended to think of science much more as an experimental way of doing things. What I wanted to determine was whether you could say that if a pre-service teacher had this notion of experimenting with science, that would show through in the way they orientated themselves in terms of teaching science in the classroom. It would be a reasonable hypothesis to raise that if somebody thought understanding phenomena was important, they would take a wholly explanatory view, for example. So from that chart there, we could make some hypotheses. So then I went to cross-match the data. Now, I've just shown you a little tiny snippet of this data here. So I took the trainees that had a constant orientation, so the ones that responded constantly in the same orientation across all 3 vignettes. And I looked to see whether, say they had, I don't know, the same orientation, did they all then show the same kind of beliefs about science? And the answer is no. I've shown you a tiny snippet of the data, and in a way this is not a good slide. But there is honestly no pattern. There is no correlation whatsoever between the kind of beliefs that these pre-service teachers say they have and the orientations they say they would use if they were to teach a topic in the classroom, which to me is quite striking. So that tells us that there are some problems here. However, let's just come to those in a second. To that first research question, what I was trying to demonstrate there was, well, what we can draw from that is that most pre-service teachers have some kind of orientation. And to me, to some extent, that was a surprise. I wasn't expecting that they would be able to answer these vignettes as confidently as they did. The strongest evidence seemed to emerge for teacher goal-based orientations, and didactic was the most common. I'll come back to that in a moment. There was no or very limited evidence for curriculum-based orientations, and again, that's not a surprise given the way that the MKB model described those orientations in the initial stages. Biologist orientation, people who hear me talk in the UK know I'm always rude about biologists, so I'm really sorry to any biologists in the audience, but biologist orientations towards physics always tends to lack conceptual coherence. So I'm sorry for that, but having heard John talk this morning, I don't feel too bad about saying that. The second question about the constancy and lability, how did that sort of work out? About a quarter show constant orientation, and a few of them show very different orientation just for their in-field subject. Now, perhaps surprisingly, biologists tend to show the most constants across any of the 3 sciences, so that's the biggest proportion, and chemists show the most in-field different. So they seem to have the strongest perception of what their subject is like and how they think they ought to teach it. So that's chemists even beyond physicists. Now, the third question about the cross-matching and the notion of where the orientations and beliefs match. Well, a majority of PSTs, again, expressed clear beliefs about science, and again, to some extent, that surprised me. There were very, very few responses to that question, which were uncodable or no response. And in the whole sample, understanding and experiment dominate, and there are some particular things about 2 of the groups. But overall, no pattern of data, no patterns emerge in the data which is cross-matched, which, like I said, was quite striking. So there's some discussion points which emerge from this, I think. Going back to Pat and Jan's concerns about this, there is evidence that there's some teacher goal-based orientations, weak evidence for curriculum-based orientations, but that dominance of the didactic group suggests that all this labelling is entirely wrong, and we need to do something which is drastically different. I'm not quite sure I agree with Pat and Jan's groupings at the moment, but clearly we need to do something more with that didactic label, because that's very, very common, but it's much, much too broad. There's this shaping influence related to content knowledge and subject matter knowledge, but it's unclear exactly what that link is because the patterns in the data were so unclear. And there is evidence that supports orientations as a general way of viewing science teaching linked to actions in terms of what people do in the classroom. There's quite a number of limitations, of course, to this study, so I'm sorry for those, but like I said, hindsight is a marvellous thing. So I think is that my 10 minutes up? Yeah. Okay, so that's the quickest talk I've ever done, but I hope that's okay. So thank you very much.